Hello.
Hello, good evening to all of you.
Good evening, sir.
Am I audible?
Yes, sir. Yes, sir.
Yes, sir. ಯಾರೋಡು ಸರ್ ಅದು ನೋಡ್ರಿ
Is my screen visible to you?
Yes, sir.
Fine. Please answer your attendance. Aditya Kumar. Aditya Kumar.
Sir, not yet came, sir.
I think
Okay.
mic off பண்ணுங்க என்ன சொல்லுங்க
Hello, sir. Mic is a problem.
Sir, it's
no I
audible.
can maybe talk here
Yeah.
sir there's a
Hello. Aditya is here. His mic, there is a problem. That's what you are saying. Okay, there is no response. Anand.
Yes, sir.
Anand Kumar. Arnachalam.
Sir, they are in the meeting room.
Hello. Yeah.
Sir, they are in conference hall. Mahendra,
Okay.
I believe there is some mic issue, sir.
இங்க கான்ஃபரன்ஸ் மைக்
So Anand Kumar, is it present? Is there an issue with the mic? What about Aditya Kumar? Present. Okay, Arnachalam, Hasan,
Present, sir.
Hemant,
present sir
Jagan,
Yes, sir.
Kesav Prasad,
Yes, sir.
Lakshmi Narayanan, Prabhakaran,
Present, sir.
Prem Vinayak,
Present, sir.
Rahul,
Present, sir.
Raujan Kumar,
Present, sir.
Sabish Kumar, Satish Kumar, Satish Kumar. Satish, are you there?
Yes, sir. Present, sir.
Okay, fine. Titus,
present sir
Vallish,
yes sir
Vigneshwaran,
present sir
Vijayaraj Balasubramaniam, Vijayaraj, Vikash,
Present, sir.
Vivekanand,
Present, sir.
Yadav,
Present, sir.
Yuvraj.
Present, sir.
Okay, there is one absentee today, Vijayaraj Balasubramaniam. Yuvraj, can you please mute your mic? Okay, thank you. So, welcome back to this course on IC engine combustion and pollution. So far, in this chapter 1, we have discussed these topics. We are in the last topic. We are currently discussing about the important fuel properties which are relevant for spark ignited and compression ignited engine application. The last class I discussed about the properties, important fuel properties that are relevant for spark ignited engine application. Today I am going to continue the discussion. Today we are going to discuss about the properties that are relevant for CI engine application. So before that, quick information. I have discussed your request with the course coordinator, Professor Manivannan, about the exams, conduct of exams. And the message received is that the students who are outstation, apart from Chennai, they will take exam at the TCS venue. TCS venue. So 3 people are there. So you will take exams at the TCS venue. I will send the question paper. Meanwhile, for the others who are in Chennai, they will take exams in IIT Madras. I have shared the information about the exam date also. I'm planning to conduct it on March 2nd, which is on Saturday at 10 o'clock. And the venue for you people is IC Engines Laboratory in IIT Madras. Okay, so the exam is on March 2nd. I have also shared the material, whatever I have discussed in the class so far. I hope.
Yes, sir. Thank you, sir. We received that.
Thank you. So, are there any further questions in this, or shall I continue with the class? Any question?
Sir, one request, sir.
Yes. Yes.
If we can get some sample questions, it will be helpful for us to have the understanding on the exam, sir.
No. I think you are going too much. See, this is at a PG level, right? PG level, we should not.
Yes.
I mean, ask for sample questions and all. Generally, I won't provide. Okay, so the exams are basically to test your understanding about the topics that have been discussed in the class. Okay, so I'm not going to ask anything outside what is discussed in the class. I've also shared the material. You have to go through the material. References also have been shared in the introduction sheet. So you have to prepare and come prepared based on the contents that are discussed in the class. There's nothing like a sample question. It can be of any type. Okay. But it will be primarily centered around whatever topics we have discussed in the class. This is basically to check your level of understanding, how you have understood the topics. Okay, there's nothing like a standard topic, standard questions or sample questions, something like that. So we will ask questions, I will ask questions based on the topics, whatever we discuss in the class. And you have all the material available with you. You have to just go through the material, that's it.
Okay, sir. Thank you so much, sir. Thank you for guiding, sir.
Fine. Anything else? I understand that it is long time you people have taken exam or studied for exam. So don't get any fear out of exam. Basically, it is to test your level of understanding. And the most important thing I always say to my class student is you need to have an interest in the subject. Once you have an interest in the subject, it won't go off from your memory. You have to. I hope you people are recording the lecture. You are taking lecture notes. So this will definitely help you. The learning that you get out of the course is more important.
Yes.
See, the marks or grades you get are based on how you do in a particular day. Okay.
Yes.
Generally, I won't believe in that. The most important thing is the learning. The final outcome is the learning that you acquire out of the course. That is more important. Okay. So I would strongly suggest you to take lecture notes, have the habit of maintaining a lecture note for all the courses you attend. May be helpful for you later on also. So listen and get involved. Once you have an interest, you will get involved, right? Then the marks will come by itself. No need to worry about that.
Yes.
So the unnecessary fear only will, make you to do some mistakes. Okay.
Yes.
Don't have any fear, have interest in the subject. Then the rest will come by itself.
Yes. Yes. Thank you, sir.
Yeah, thank you. So this is what we have discussed in the previous class. We have discussed gasoline fuel properties, which are relevant for spark ignited engine application. I've also briefly said about this fuel legal specifications, like legal emission specifications. Fuel also has some standard specifications in different countries. In India, we have this BS6 specification. Currently, we have BS6 emission norms. So the fuel quality also should comply with the current emission norm. So we refer it as BS6 fuel specifications. Any fuel legally sold in the market should comply with this value. Like any vehicle sold legally in the market should comply with the emission norms. The fuel that is sold in the market in all our pumping stations should comply with these norms. These are the legal fuel limits set by a group of organization. I said about IIP, Indian Institute of Petroleum, Dehradun, IOC, Indian Oil Corporation. These are some of the governing bodies. So there are a group of partnering people who are involved in developing fuel. Okay, so those are the people who set the specification. They provide these limits for the fuel property. They also provide the procedure to test the property. The idea here is we need to follow a standard protocol to test the fuel, and also this limit should be complied. As I have said, the objectives behind this fuel legal specifications I briefly discussed in the previous class. So the major objective is, as an end user of a vehicle, they should not have any problem with respect to engine starting or combustion noise or the required fuel and power. It should be delivered, and it should have a long durability. The vehicle should be durable. So fuel has a significant role to play in all these aspects. Okay, that is what we are seeing here. These are the various effects of important fuel property. I have provided here only important fuel property. Other than this, there are other properties which also have a role. I picked up only the important properties that are having significant effect. As we could see in the middle column, these are the significant effect of these properties on the engine. So the legal standards are fixed. Okay, specifications are fixed primarily to ensure that the end user of the vehicle has no problem in using a particular fuel. Okay, that is the objective that we have discussed. Okay, so now in today's class, as I said, we are going to see diesel fuel properties which are relevant for compression ignition engine application, CI engine application. As I already said in the first class, CI engines, diesel engines are the most versatile engine. You can design a 3 kilowatt diesel engine as well as 30,000 kilowatt diesel engine. They have a wide range of application. Okay, both on-road automotive as well as off-road. Several off-road diesel engines are also there. This is the BS6 value for these properties, important fuel properties. Okay, and these are the effects on the engine, effects of these properties on the engine, CI engine. I'll give more details about C10 number and volatility in the subsequent slide. The next property that you see here is density. According to the legal specification, the values 810 to 845 is a range. Fuel density of the diesel should comply within this range 810 to 845. It should be measured at this temperature. At this temperature, these are the values, legal limits of fuel density. As you could see here, one of the observation is it is high as compared to the density you could see for gasoline or petrol. It is around 720. This is around 810. The diesel density is always high. Based on our discussion on molecular composition, can you think of something that caused this high density for diesel?
It is having the more dense distillate.
More dense distillate, heavy hydrocarbon, right?
Heavy hydrocarbon, right, sir.
Okay, diesel has heavy hydrocarbon, as you rightly said. So because of that, the density is high. This is one of the reasons why diesel vehicle generally, this is one of the reasons why diesel vehicles generally provide more mileage as compared to petrol or gasoline vehicle. The fuel density is high, and the high density fuel will affect fuel economy. We already discussed here for gasoline, we meter fuel on volume basis. Metering is the process of controlling the fuel volume for each engine operating cycle. So we have an injection system that takes care of allowing only a metered quantity, precise quantity of fuel into engine for each operating cycle. Okay, so we meter fuel on volume basis. Because of that, any variation in density will reflect in the mass of the fuel that is injected into the engine cylinder. You know, you are controlling diesel engine power output by varying the injected fuel mass. Air is unthrottled. We call it as unthrottled operation. The air mass is fixed. Only fuel mass is regulated or controlled to vary the power output. When you move from low load to high load, you are actually increasing the injected fuel mass. Since we meter fuel on a volume basis, Any variation in density will reflect in the mass of the fuel that goes into the engine cylinder. High density fuel is preferable from that perspective because for the same volume, the mass that goes into the engine cylinder will be high, because of higher density. Higher mass is preferable because more energy will be released during combustion. In other words, for producing given power output, it is enough to burn less fuel quantity. Okay, because of that, you could end up in having a better mileage or better fuel economy if you have a high density fuel, but there is an upper limit, as you could see here. We cannot have a very high density fuel that will have other effects. Okay, one of the effects, as we have discussed, is it causes more deposits. In diesel engine also, the more severe problem is the particulate emission. Okay, solid particles, soot particles are generated in diesel engine, only in diesel engine, not in SI engine, because of the nature of the combustion event that we are going to see in the next chapter. Okay, so here the high density fuel, diesel fuel, primarily affects the particulate formation. Okay, so there is an upper limit, and one of the interesting aspect of fuel density only for CI engine application is, apart from fuel economy, it also affects the spray characteristic as well as SOI. SOI here stands for start of fuel injection. Diesel density variations also affect start of fuel injection. I will show you now how it affects start of fuel injection. Here you should note that this effect is the effect of density on start of fuel injection is applicable only for mechanical fuel injection systems. This is not applicable for electronic fuel injection system. Most of the current on-road automotive engines have electronic fuel injection system. They use common rail direct injection system. Okay, for those engines, density has no role, but we use this mechanical fuel injection system primarily in off-road diesel engine application. For example, the engines used to use for irrigation purpose, for pumping water for agricultural land, those diesel engines still use this mechanic. This is what I mean by off-road application. They still use mechanical fuel injection system because of lower cost. That is a primary consideration. Once you have a mechanical fuel injection system, any variation in fuel density affects the start of injection timing. Let us quickly look at how it affects start of injection timing. So there are two timings here, as I have indicated here. One is called static timing and the other one is called dynamic timing. Static timing is the time at which the fuel pump opens and delivers fuel into this line. This line is a high pressure fuel line. So once the fuel pump opens, the fuel is let out to high pressure fuel line, then it reaches the injector. Okay, from the injector, it is sprayed into the engine cylinder. You know, injector has a needle that always remain closed. It's a spring loaded needle. Okay, it remains in the closed position. Whenever you have a fuel with a higher pressure, if it overcomes the needle force. Needle force is primarily because of the spring force. Okay, so once you have a fuel with a higher pressure, once it overcomes this spring loaded needle force, then the needle lift, it opens and sprays fuel into the engine cylinder. Okay, that is how this mechanical system works. So actuation is by mechanical. In a CRDI system, this needle lift is controlled by energizing solenoid. So you are externally controlling the solenoid energization time. Thereby, you are externally controlling the time at which the fuel is sprayed. This is not the case with mechanical system, wherein you have a mechanical actuation system. You have a spring-loaded needle. Whenever the fuel pressure overcomes the spring force, the needle is going to lift and the fuel is going to be sprayed. Because of this, this static timing is set by the OEM. Okay, so they will set based on the engine design, the static timing is set. The time at which the pump open and deliver the fuel in the high pressure line is set. But what is different is the dynamic timing. Dynamic fuel injection timing is the time at which the needle lift and sprays fuel into the engine cylinder. This is one of the important fuel injection timing that affects the combustion phenomena, because the time at which the fuel is sprayed into the engine cylinder will carry a lot of significance. Not this timing. This is not of much significance in terms of combustion analysis. What is important is the dynamic timing. And this dynamic timing depends on how quickly the fuel travels in the high pressure line. How quickly the fuel travels in the high pressure line is affected by density. When you have a high density fuel, it is of less compressible nature. Because of this, the fuel will travel at a higher velocity in the high pressure line. At a higher pressure, the propagation of fuel can be treated as acoustic wave propagation. Okay, it happens at a very high pressure. It is like a wave propagation. When you have a high density fuel, because of its less compressible nature, the fuel will travel at a higher velocity in the high pressure line, due to which the dynamic injection timing will be advanced. When you have a low density fuel, the fuel velocity will be relatively less in the high pressure line. Accordingly, the dynamic injection timing is retarded. So you may have an advanced or retarded dynamic fuel injection timing based on the density variation, because it affects the velocity at which the fuel travels in the high pressure line. Meaning, for the same static timing, the dynamic timing could be different based on variations in the fuel density. This is the effect of fuel density on the injection timing, which is applicable for mechanical system. And this is not relevant for electronic system, as I said, because we actuate needle lift externally by energizing the solenoid. So density affects fuel economy. It affects startup fuel injection in the mechanical system. It also affects spray characteristic. We have discussed this in the beginning of this chapter. Density also affects the density also affects the fuel spray characteristic. Fuel, two important characteristics of fuel spray are: one is penetration length, that is the maximum length at which the fuel penetrate. This is the penetration length, as you know. And this one is the angle, included angle. This angle is called spray cone angle. This we have discussed in the beginning of this chapter 1. Based on density variation, this penetration length could be different, because the length at which, the maximum length at which the spray penetrate in the combustion chamber is dependent on the momentum of the spray momentum. What is momentum?
Mass into velocity.
Yes, momentum is mass multiplied by velocity. You know, velocity can be fixed based on
Pressure difference.
pressure difference, delta P. Fuel injection pressure will fix the velocity at which the spray moves inside the combustion chamber. Please note that the spray is moving inside the combustion chamber against the air resistance. What you have inside the cylinder? Air at a higher pressure and higher temperature. Air is going to offer resistance for the spray movement, and the spray is penetrating against the air resistance. That's why we use delta P here. So the velocity at which the spray moves is fixed by delta P. But what is different here? Mass can be different based on density variation. Density is mass per unit volume. As I said, any variation in density, increase or decrease in density, will affect the mass that goes into the cylinder. High density fuel will result in higher mass of fuel injection, as we have discussed just now. This will increase mass. When the mass is higher, what will happen to penetration length? Momentum will be more. For the same velocity, the momentum will be more. So what will happen to penetration length?
It will be more, sir.
It will be more. Okay. So the fuel may penetrate more in the cylinder. So this is a photograph of typical fuel spray. So the spray may penetrate more into the engine cylinder if you have a high density fuel, because for the same velocity, the mass that is injected is dependent on the fuel density. So high density fuel allow more mass, thereby the penetration length will be more. Too high penetration length may cause some problem, especially when the engine bore is less. What will happen with the high spray momentum and more penetration? It may go and hit the cylinder wall. You know, wall is the cooler region in the combustion chamber, right? Because near the wall, you circulate the coolant. Near the wall, you circulate the coolant. So what will happen? Like I have shown a sketch here, if the spray momentum is more, the spray will go and hit the wall. Once it hits the wall, it will form a film, like I have shown here. This film will take more time for vaporization, because this is a region where the temperature is less. Near the wall, you are actually circulating coolant, right? So this is a coolant flow region. So once you form a film in the wall, it will take more time for the film to vaporize. You know, vaporization has to take place quickly in the engine cylinder, right? We are talking about the time scale of microsecond or nanosecond. That is the time scale. So this film will take a longer time for vaporization. Eventually, it will end up as an unburnt emission from the engine. This is one of the mechanisms at which unburnt fuel emissions are formed from a diesel engine. We are going to discuss more about this later on in the second module, emission module. But just take a note that this is one of the mechanisms at which unburnt emissions are formed. Okay, so density has a role because density affects the penetration length through its effect on the spray momentum. Also, high density fuel generally have a larger drop size. So we discuss about this. Larger drop size will also delay the vaporization even because larger the drop size, the vaporization even will be delayed. We want a very fine drop. We call it as a finer atomization. Okay, very small or fine drop will result in quick vaporization. Larger drop will delay the vaporization even. Okay, eventually it will affect the mixing and thereby it affects the combustion phenomena in the diesel engine. So these are the effects, typical effects of fuel density in a CI engine. It affects fuel economy, it affects spray characteristic, it also affects the injection timing only in mechanical system.
Sir, I have a question over here. I'm sorry to interrupt. Sir, you told that since fuel pump will supply the what I mean to say is with a constant pressure, and injector will have a set pressure by OEM. So if we have higher density fuel in the line, it will have higher velocity because of same pressure difference. The higher density fuel will travel at a higher velocity. That is clear, sir. But you use the word advance and retard,
Yeah, I will talk more about advance and retard. Advance and retard is a qualitative term. Okay, so when I say advance, it's on a relative sense, not an absolute sense. Suppose if you have a fuel injection timing of 20 degree as a standard or optimized value, okay. If you have a high density fuel, it will inject fuel at a timing of say 22 degree or 23 degree. This is what I mean by advance. When I say retarded injection, compared to the standard timing of 20, you will be spraying fuel at a timing of say 18 degree or 17 degree before top dead center. Again, this timing reference is based on top dead center, before the piston reaches top dead center.
So won't it be like more fuel is entering to the chamber for the high density fuel?
Yes, there will be more fuel and there will be effect on the timing only in the mechanical system. Mass is more and timing is advanced in the case of mechanical system.
So both will get impacted, like mass of the fuel and timing.
Yeah, mass will change both for mechanical system as well as for electronic system. Timing will change only for mechanical system.
Okay, sir. Thank you. Thank you so much.
Okay. So these are the effects of density. Then you have viscosity here.
Yes, sir.
Yeah.
Sir, one doubt. If we change the design of the piston head, can you avoid this wall wetting phenomena?
Wall wetting phenomena, in fact, is not dependent on the piston design. It is primarily dependent on the your timing, injection timing. Timing will have a more severe effect. Piston design will affect whether you are carrying the required fuel spray into the bowl region or other region. Okay, that will happen when how far is the piston with respect to the timing of fuel injection. When the piston is far away, whatever bowl design you make, it is not the bowl is not taking the fuel spray, right? When the bowl is away, when the bowl is nearer, it will take. When it is away, it won't take. It won't take the fuel. So the timing of fuel injection will play a significant role. This is what I.
So you are telling that. Yeah. So you are telling that the 10 to 20 degree, if you are playing with that, it will reduce that wall wetting phenomenon.
That will, yes, that will have a more significant role. That's what I'm saying. Once the piston is nearer, okay, nearer to the top dead center, the bowl will take the spray. There, the bowl, the way you design the bowl, hemispherical or any other bowl, I will talk more about it in the next chapter, that bowl design will play a role when the piston is nearer to the top dead center. But when the piston is far away from top dead center, bowl design has no role.
So I was thinking of the same only. In addition to the reducing this, what is it, the timing, and if we make this piston head change, that so if we are adding both together, so that will help.
Yes, definitely. Both can be optimized. So we use we often use the word optimization, right? You need to optimize both based on the timing of injection and the bore. In fact, the bore will play a role. If you have a small bore engine, the wall wetting is severe generally.
Okay, thank you.
Okay. So next we have this viscosity. These are the limits 2 to 4.5 mm square per second according to BS6, and viscosity according to the standard, it is measured at 40 degrees Celsius, and these are the values, viscosity value. Viscosity of the fuel has important role to play in these two parameters. One is it affects the way the fuel is injected. So you know how a oil moves and how a water moves, right? Viscosity is one of the fundamental property. It is, in simple term, it can be defined as flow resistant. Oil has more flow resistant. It moves slowly because it's highly viscous. Water moves quickly because it is having less flow resistant or less viscosity. Okay, so high viscous fuel need more energy to pump in. This is one important inference based on the fundamental definition of viscosity. And the second effect it will have on the injection system is, if you have a high viscosity fuel, the leakage from the system. So you are dealing with high pressure system, right? Your entire fuel injection system is under higher pressure. It is prone to leak. When you have a high viscous fuel, the leakage losses are generally less. Okay. But if you have a low viscous fuel, then you can expect that the leakage from the system is more. This is one effect. And second one, as I said, flow resistance is more when you have a high viscous fuel. Because of more flow resistance, the mass of fuel that is finally sprayed may get reduced if you have a high viscosity fuel for the same power that you give in the pump. So you're comparing two different fuel, one with high and one with low viscosity. So high viscous fuel will have more flow resistance. Because of higher flow resistance, the mass that is finally sprayed into the engine cylinder may get reduced. Okay, so viscosity, that is how it affects on the injection system. Okay, injection system, it affects leakage. It also affects the flow friction. On the spray characteristic, as we know, if you have a high viscous fuel, again the drop size will be high. High density and high viscous fuel generally will result in higher drop size that may delay the vaporization event, and the overall effect is poor combustion. So we want the fuel to vaporize quickly, and high viscous fuel will also, like density, it will also cause higher or larger drop size that will delay the vaporization, and because of that you will have a poor combustion. Poor combustion is primarily due to poor mixing, and poor mixing and poor combustion in a diesel engine will have higher pollutants, as we know. We will discuss more about it in the second module, which is on emission formation. So we will discuss about the mechanisms, various mechanisms. One of the mechanism is the spray characteristic in a diesel engine, because we know that the combustion event in a diesel engine is referred to as mixing limited combustion. How effectively you carry out fuel or mixing carries a lot of significance for diesel engine. Heating value. Heating value effect is same as what we have discussed for gasoline. Heating value affects energy release. And this is expressed in terms of megajoules or kilojoules of energy release by burning unit mass or unit volume. We prefer to have a higher heating value fuel because it implies that you have more energy content in the fuel. If you have a high energy content fuel, it is enough to burn less quantity of fuel, okay, to produce the same power output. This will have two effects. One, your fuel storage system in the vehicle will be compact because of higher energy content of the fuel. On the other hand, if you have a lower energy content fuel, you have to store more. Otherwise, you have to refuel your vehicle often. Okay, this is one effect. Second effect is, as I said, it is enough to burn less quantity of fuel to produce a given power, meaning it will also reflect in better fuel economy. Okay, so compactness of the system and fuel economy both are affected by the heating value. Flashpoint, it has to do with safety aspects. We already discussed here. Similar things are applicable here, and diesel generally is safe. Although the fuel regulations limit it to 35 degree, diesel flash point temperature is around 60 degrees Celsius. So you know flash point temperature is the ability of the fuel to produce momentary flash in terms of an ignition source. In presence of an ignition source, how quickly the fuel forms a momentary flash is indicated by this temperature. Okay, diesel won't form a momentary flash because the flash point temperature is high, meaning that it will form very lean mixture that cannot be ignited even in presence of a ignition source. So it is a safer fuel for storage and transportation. We have already discussed that gasoline and diesel are used for such a longer period. One of the reason is these fuels are very safe during storage and transportation as compared to any gaseous fuel or any other alternative fuel. There are two other properties. These two properties are applicable only for CA engine. One is lubricity and other one is CFPP. Lubricity, this CFPP is called filter plugging point, and this lubricity is a measure of ability of the fuel to lubricate injection system component. Here we should note that we are not using a separate lubricant in injection system because of the close tolerances. Fuel itself should act as a lubricant in an injection system. So the ability of the fuel to lubricate injection system component is defined by this property, lubricity. When you have a fuel with better lubricity characteristic, you can expect a longer life for the injection system. Otherwise, the life of the injection system will be shorter. And this is measured in terms of something called a wear scare diameter. That is what you are seeing here. It is given in micrometer, 460 micrometer. It is called wear scare diameter. I will quickly show the setup that is used to measure this lubricity. As I said, this property lubricity is a measure of ability of the fuel to lubricate injection system component. Okay, it is preferable to have a better lubricity fuel so as to increase the life of injection system component. And this property is defined in terms of wear scare diameter, and this is measured by using a test setup called HFRR. This HFRR is called high frequency reciprocating rig. High frequency reciprocating rig setup. I've provided a simple schematic of that setup. You have a steel ball here. Steel ball. It reciprocates for a well-defined duration. It's around 75 minutes. And this ball, steel ball, reciprocate in a steel plate. As you could see here, that it is reciprocating in a steel plate, and the plate is filled with fuel. The steel plate is filled with fuel, and a ball, steel ball, is allowed to reciprocate for a known duration of 75 minutes. Okay, with a known load. Okay, the load is defined, the reciprocating time is defined, and the ball is reciprocating over a steel ball, over a steel plate wherein you have a fuel, finite quantity of fuel. Okay, so what will happen after this time? If you have a fuel with a better lubricating property, it will minimize the friction between the steel ball and steel plate. If the fuel has a poor lubricating properties, it is going to increase the friction in the steel ball. Basically, we are creating a boundary lubrication regime here, and we allow steel ball to reciprocate on the plate for a known time. After this time, the wear scare on the steel ball is measured by using a microscope. Okay, and which is what you are seeing there. It is preferable to have a less wear scare on the steel ball. The less wear scare on the steel ball indicates that the fuel has a better lubricating property. Okay, so this is one of the important property which are applicable only for diesel fuel for CA engine application, because in CA engine we deal with high pressure injection system. So the durability of injection system needs to be increased, and fuel needs to have better lubricity property. Next, you have this CFEP, which affects cold start characteristic of diesel engine. Again, this is applicable only for diesel fuel, not for gasoline. You could not see CFEP for gasoline. Can anyone tell me why the CFEP is regulated only for diesel fuel? This is a minimum value, 6 degree. It is preferable to have a lower value than this, not higher value. Okay, can you tell me why this CFEP is regulated for diesel, not for
It is less
gasoline.
volatile. It's less
Yes.
less volatile, sir. So if
Less
the,
volatile.
The flash point for petrol, gasoline is already, I think, sub-zero, right? So I think that could be one reason.
Flashpoint
Yes, sir.
0. Okay. So because of that, you are expecting better CFPP also.
Correct. Yeah. So it is automatically ensured, but for diesel, I think it's somewhere at a higher temperature, right? Like
Higher, yeah.
in the ambient temperature. So that's why
60 degree.
specifically mentioned.
Anything else you can think of from molecular composition perspective?
Yes, sir. Like movement of molecules should be there at means up to 6 degree centigrade temperature, so that it atomize and vaporize.
Yeah. So no. Well, my question is, anything you can think of in terms of molecular differences in molecular composition of gasoline and diesel? Differences in molecular composition of gasoline and diesel? Anything that?
sir, this is basically open chain, like paraffin type of fuel, which is less volatile compared to aromatics.
Yeah.
So what I mean to say, cold start may the most important property that a fuel should have is it should be volatile and under the cold condition. If it is not like what I mean to say is volatile, then it will be forming a like incombustible mixture type of thing. So
Okay.
because of that, probably this is important aspect. What I mean to say, so we should be defined with that.
So yeah, so this is a molecular composition we have already discussed for gasoline and diesel. Gasoline has low molecular weight hydrocarbon, and they are highly volatile, light distillate. Diesel consists of heavy hydrocarbon, as you could see from the carbon number distribution, C9 to C23. The primary contribution is from C14 to 18. So it's a heavier hydrocarbon, high molecular weight hydrocarbon. You know, the high molecular weight hydrocarbon, the problem with the high molecular weight hydrocarbon comes into picture during cold weather condition. So when you run your vehicle in cold weather, India is a tropical country, temperatures are generally high. But in India, northeast state, you know, the surrounding temperatures are low. Western countries, it's more severe. During winter, it goes to negative temperature, right? -20, -30. Very low operating temperature, ambient temperature. So you need to run your vehicle under those very low operating temperature. What will happen if you run your vehicle under those conditions? Diesel, because of its heavier hydrocarbon, this heavier hydrocarbon start to solidify. So you need fuel with the required fluidity to flow quickly from the tank to the injector. Okay, you know, you are storing fuel in a tank. From the tank, it should go to the feed pump. From feed pump, it goes to high pressure pump, and then you have a filter. Okay, the feed pump region itself, you will have a fuel filter, then you have a high pressure pump, then you have a high pressure line. From the line, it goes to the injector. So fuel travels a considerable path from the tank to the injector for each cycle. When you have a very low surrounding temperature, ambient temperature, and when you have to deal with such heavier fuel, this heavier fuel will start to solidify. It will start to form something called a wax crystal in the fuel line. Once the crystals are formed, the fluidity will get reduced. The fuel may not be able to flow quickly from the tank region to the injector. The worst case scenario is if the temperature is too low, this wax crystal formation will increase and the crystals will finally clog the fuel filter. Once the filter is clogged, you know what will happen. There is no more fuel delivery to the injector. There is no more fuel delivery to the cylinder. The engine will become inoperative. This is a severity of the problem in dealing with such a high molecular weight hydrocarbon based fuel in a cold ambient condition. Okay, so this property is what is the CFPP. This is cold filter plugging point. Okay, and it affects the cold start characteristic. In our country, it is fixed at 6 degrees Celsius. Okay, so this is measured by using a specific setup. So what is done here, as I said, this property is a measure of ability of the fuel to flow quickly from the fuel tank to the fuel injector. Okay, and how they measure this cold filter plugging point, you have seen a number 6 degrees Celsius. How they do it, they have a controlled test setup. In that, they will reduce the temperature of the fuel and check whether a finite volume, the volume is defined here, 20 ml of fuel, whether it can quickly flow through a 45 micron mesh. Typically, they are simulating a fuel filter. Okay, they are simulating a flow of fuel in an actual vehicle by having this setup. They allow a finite volume of fuel through a filter of 45 micron mesh, and they check whether the fuel can flow quickly through this mesh. The time is, it should be less than a minute. Okay, once they reduce the temperature, what will happen? The wax crystal formation will take place, and the flow of fuel will be affected because of the formation of wax crystal. The fuel may not flow quickly. Okay, the fluidity is affected. So the CFPP is a minimum temperature at which the fuel, known volume of fuel, 20 ml fuel, can flow through 45 micron mesh in less than a minute. Okay, this is the controlled environment. These are the conditions imposed, and based on these conditions, they fix the temperature value. Okay. Yes, someone was asking something.
Sir, is lubricity related to viscosity, or it is different?
It is different actually. It's more complicated property than what you think, because it has to do with the molecular composition. Today we talk more about ultra low sulfur diesel, right? Sulfur, when sulfur content is more, the lubricity properties are better. When sulfur is reduced, lubricity is poor. Sometimes we also use some additive, lubricity enhancer additives are used because the polar compounds present in fuel is what is reducing the friction in the injection system. Basically, the fuel film has to minimize the friction during metal-to-metal contact, which are either in rotary motion or reciprocating motion.
Right, sir. Thank you.
Okay. So that is how we measure this CFPP. Yeah. Yes.
Sir, one doubt, sir. Like if the lubricity is better, wall wetting for phenomena will increase, or how it is, sir?
Wall wetting, spray wall wetting.
Yeah. Yes.
Spray wall wetting and lubricity cannot be directly correlated. Lubricity of the fuel has to do only with the ability of the fuel to reduce friction in the injection system. Okay. Ability of the fuel to reduce friction in the injection system is defined by this property. Spray wall wetting is altogether a different phenomena. Spray wall wetting is severely affected by density, as I said now.
Okay, sir. Sir, means there will be a thin film between the piston rings and the bore. So, like, I was just anticipating in that way, like how it will be.
No, this film and that film was different. So the film that I said about for lubricity is about preventing metal-to-metal contact. Okay. The film that you are talking in the engine cylinder is the film that is formed around the wall region, cylinder wall region. Okay. Cylinder wall region, and that film, once it forms a film, it takes more time for vaporization and mixing. So when we define lubricity, it is only on the injection system, okay, which is outside the engine cylinder. Spray wall wetting is inside the engine cylinder. That affects the mixing and combustion. Do you understand?
Okay, understood. Understood, sir. One more doubt, sir. What kind of film thickness will be there between the piston ring and the bore? Means
that will be
micron size, sir?
Yeah, it will be micron size. It will be micron size also.
Okay. Okay.
Very thin film. Okay, thin film only form. Why it is thin is because of the pressure. So you inject at a very high pressure, so it allows to form only a very thin film. Okay.
Right.
Thank you, sir. Thank you.
Okay.
Sir, I want to ask one question, sir. Sir, the petrol, some companies like HP and IOCL, they market their product as power petrol. Shell is there. There is one company which is also providing the fuel at a very high cost. So, sir, basically, what are the properties they modify in like listed over here? Do you have any ideas? I'm sorry, I just just a query, a generic query. Sir.
So it is a commercial interest. They don't disclose, okay, what they modify, but what they claim is the power will be high, and they help in running the vehicle at a higher speed with the more power output. But the composition, what type of fuel composition modification they do, they generally don't disclose. But definitely there will be difference in the density and other fundamental properties. There will be some difference in that.
So, sir, have you tested in your lab, sir, anything like this?
High density, no. Normal general commercial fuel only we focus on. This special formulations based on any specific request. We have tested a lot of additives, but there are no requests from IOCL as such to test the power fuel and normal fuel.
Right. Thank you, sir.
Okay. So then you have these two composition. It's not property. One is aromatic and second one is sulfur. Aromatics in a diesel engine, aromatic content is regulated, as you could see here. This PAH is polyaromatic hydrocarbon, which will have more than one benzene ring. That is what is polyaromatic, and it is regulated up to 8% according to the specifications. This higher aromatic content, the problem is it will produce more pollutant. You know, these two are the major pollutant from diesel engine. I will talk more about how these pollutants are influenced by aromatic content, but here just take a note that when you have more aromatic, it means it can form more soot particle. Soot are nothing but carbon particle. You will have more carbon particle, soot particle, when you have a high aromatic content in the fuel. Okay, and high aromatic content is also known to cause higher flame temperature. Higher temperature will form high NOx. One of the primary mechanism at which NOx oxides of nitrogen is formed in the cylinder is due to higher temperature. Aromatics are known to cause higher temperature during combustion, and thereby it forms NOx. So you could more detailed discussion I will provide in the second module about this mechanism involved. I will provide more details in the second module. But here just take a note that any increase in aromatic content in the diesel fuel will increase both soot and NOx from a diesel engine. Sulfur is again a composition. Today we talk about ultra low sulfur diesel fuel. In fact, between BS4 and BS6 fuel, the only difference comes here in terms of sulfur content. Earlier it was 50 milligram, now it is reduced to 10 milligram. So this is what we refer it as a ultra low sulfur diesel, because sulfur affects after treatment device. We have discussed this in gasoline case also. It affects three-way catalytic converter. It makes the catalyst like platinum inactive. It will make it inactive, and catalyst like platinum are very expensive. So you may have to often change the catalyst, which is going to be a higher maintenance cost. So here also after treatment system is affected by sulfur. I will give more detail later on. Here we have DOC, diesel oxidation catalyst in a diesel engine, and the catalyst used there will be affected by sulfur oxides. It also increases particulate emission. Any increase in sulfur content directly reflect in higher particulate emissions. Okay, and that's why we regulate it and keep it within a limit. Okay, so this is the effect of sulfur. More detail about these pollutant will be discussed in the second module. It's time up. I stop here. If you have any questions, I can take your questions now.
Sir, one question, sir. You had shown some graph about what is the impact of the aromatics like fuel composition on the ignition delay for the diesel for the CI engine.
Mm-hmm.
So will the trend get reversed in case of what I mean to say SI? Like if you can go to the graph, sir. Like what I mean to say, exactly, sir. So C10 number is there, and then ignition delay is there. So these type of trends will that be reversed for gasoline engines, gasoline fuels, like octane number versus ignition delay will not come in what I mean to say is in SI engine. It will come probably anti-knock property in that, right, sir? If I'm not wrong.
Yeah. So here, so in a diesel engine, we have discussed about this trends, ignition delay trend with molecular composition. In a SI engine, spark ignited engine, technically there is nothing called ignition delay time because you discharge electric spark. Okay. And because of high thermal energy that you provide, ignition happens almost instantaneously. There's nothing called a delay. Here there is a delay because it's a self-ignition.
Right.
Before self-ignition, there are so many processes that are taking place. We already discussed about that. Okay, physical delay and chemical delay. This is applicable for diesel engine or CI engine because of the nature of ignition event. Nature of ignition event here is self-ignition. This is not the case in SI engine, wherein the nature of ignition is spark discharge, through spark discharge. And you are discharging a very high thermal energy through the spark, electric spark, and you make the mixture to ignite because of the high thermal energy that you provide. So technically, there's nothing called a delay time. And technically, you cannot relate the combustion effect on the delay time for SI engine. That is a direct answer to your question. The delay time that we define for SI engine is based on how much time is required to form a stable flame. There is no delay for ignition, but there is some delay to form a stable flame. That time is sometimes encountered as ignition lag or delay time in SI engine. Is it clear?
Right, sir. Right, sir. Right, sir. Thank you.
Okay, thank you. Any other questions?
One question, sir. For diesel, like CFPP, you mentioned BS6 diesel, it is 6 degree. For cold start, can we consider anyway 6 degree it will start, but can we consider that is the minimum temperature we can run the vehicle, or we can still further go lesser than 6 degree?
No. That is according to the specification standard. You have the 6 degree. Okay, it is preferable to have a lower value. It is preferable to have a lower value. This is a fuel property. Okay, fuel property and regulations set 6 degree for this particular property. When the value is higher than 6 degree, what it means is if you run fuel with such say 10 degree or 20 degree, okay, say if the CFPP value is 10 degree, when you run your diesel vehicle with fuel having a 10 degree CFPP, then what will happen? The engine may become inoperative because its tendency to form wax crystal is at a relatively higher temperature.
Okay.
It's preferable to have a lower value. This is the limit. It can be lower than this, but it should not be higher than this. Higher than this will affect the vehicle operation.
Because right now we are getting basic everywhere. Like the vehicle what we are running, like some places we are like will be running at zero condition also with basics. So will it operate or that?
It will operate. Actually, it should be regulated based on the seasonal variation. For summer and winter, it is totally different. Ambient temperature is different. So your question is whether the engine will run in a northeast state wherein the temperature is much lower than this, right? And I have a fuel with a higher value than this. But the surrounding ambient temperature is much lower than this. It will run. The vehicle will run. The thing is, you have to use some additive. Otherwise, you cannot make your vehicle operative. This is for the diesel fuel standard value. Okay, but you may have to use some additive if you are running your vehicle under very low temperature values. So think about Western countries, -20, -30. So as I said, they will use additive, one thing, and they will also have some starting aid. They will have a heating system and all that will take care of increasing fluidity. Okay.
Thank you.
Yeah. Okay. So it's time up. Yeah. You have one more.
Yes, sir. Sir, this sulfur content you have mentioned, sir. This for diesel.
Yes.
So say BS4, the energy will differ from different sulfur content.
Fuel energy, fuel heating value.
Yes, sir. Yes.
Sulfur has no role on the heating value. Heating value primarily is dependent on the carbon and hydrogen content. See, this value, sulfur value you're talking is 10 milligram per kg, right? And the majority of the elements are carbon, 84% and 14% hydrogen. So it is almost 98% of the total fuel composition. Sulfur is coming as a trace element. These changes in the composition of sulfur do not affect much the heating value.
No, you have mentioned PM 10 milligrams like that. Maybe if we use this fuel, PM will reduce and NOx will increase because of that's why I asked.
Yes, pollutant level will be different. See, pollutant level you are measuring in ppm level, right? 1 by 10 power 6, that is ppm.
Correct, sir. Correct.
So pollutant level will be different because we are talking about ppm level time, ppm level scale. Magnitude is very low. Okay, but heating value you are talking in terms of megajoule or kilojoule per kilogram. It is a larger value. Okay, the major elements only will affect. Major elements in fuel are carbon and hydrogen.
Okay, okay. Thank you.
Is it clear? Okay.
Yes.
Okay, fine. Okay, shall I stop here?
Yes, sir. I think Vijayaraj just joined lately here. So,
Who is that? Vijayaraj.
Hi, sir.
Okay. Is there any reason for joining late?
Sir, I got stuck up in a meeting around 20 minutes late.
Okay, I think you should join in time. Hmm?
Yeah, make it.
Okay, fine. Thank you. I stop here. I will see you tomorrow. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.